All right, number 28. Find a rational zero of the polynomial function and use it to find all the zeros of the function. So again, we could list out our p divided by q's. Your p's here are going to be your factors of 6, 1, 2, 3, and 6. Your q's are your factors of 3, so 1 and 3. So your plus or minus p divided by q's, which are all your potential zeros, are going to be, we'll divide all of your p's by 1, so that's plus or minus 1, 2, 3, and 6. And then divide all of your p's by 3, so that's plus or minus 1/3, 2/3, plus or minus 2/3. Plus or minus 1 we already have on our list, and then plus or minus 2 we already have. So those are all of the potential zeros. Now you notice that in this list over here, in your multiple choice options, you only have 4 options to choose from. So maybe don't try plus or minus 1, plus or minus 2. Maybe start with plus or minus 3, because you don't even have 1 or 2 in your multiple choice options. So I'm going to start with 3. Just a test taking strategy, right? Oops. Okay, that one obviously doesn't give me a remainder of 0, so I'm going to move to -3. Not a remainder of 0, so I'll move on to do, let's see, 1/3. All right, that one gave me a remainder of 0, so that means 1/3, positive 1/3, is a 0. So that's the only one that has positive 1/3, so that must be the answer. Now, how would you get those other two answers, the square root of 6 and negative square root of 6? Well, the polynomial that I have here, after I've divided out my x minus 1/3, or 3x minus 1, is x squared minus 18. Now I could just add that 18 over. So I have 3x squared equals 18. Divide by 3. Take the square root. And I have plus or minus the square root of 6. Okay, to get rid of a square, you take the square root, and don't forget the plus or minus. So that's how you would get those other two answers if there were more than one option for you to choose from there. So one of my zeros is 1/3, because I got a remainder of 0, and then the other two are plus or minus the square root of 6. All right, number 31. This is a different type of question. So it says find an nth degree polynomial, so n equals 3 in this case, polynomial function with real coefficients satisfying the given conditions. So the degree of your polynomial is 3. That tells you two things. That tells you should have 3 zeros, and that tells you that your degree here, that largest exponent, should be 3. So the zeros that they give me are 3 and I, but I know that I should have 3 zeros, so what's the third zero? Well, if I is a 0, then its complex conjugate, negative I, should also be a 0. So 3i and negative I are my 3 zeros. So I'll have f of x, just writing that in factored form, equals x minus 3, x minus I, and x plus I. Now, what do we use this for? Well, we need to figure out what our leading coefficient is going to be. So I'm going to put an a here, and then we're going to plug in 2 for x and 25 for y, right? Because this is the point. X is 2, y is 25. So we're going to plug those in to solve for a. All right, we'll do that first. 25 equals a, 2 minus 3, 2 minus I, 2 plus I. You can do it at the beginning, or you could multiply all of this together first and figure out what, and then plug in 2 and 25 at the end. Actually, I think on this one, that's what I want to do. You can do it right here, or you could do it at the end. So let's do it at the end on this one. You'll get the same thing either way. So first you want to multiply the two that have the complex conjugates together. So that's the x minus I, x plus I. You want to FOIL those together first. So I get x squared plus ix minus ix minus I squared. Well, I squared is -1. So that's negative times -1 gives me positive 1. My ix minus ix cancels. So now I have a times x minus 3 times x squared plus 1. Okay, now let's FOIL these two together. So that gives me x cubed minus 3x squared plus x minus 3. All right, now here's where I would plug in 2 and 25. So plugging in 25 for f of x and plugging in 2 for all of these x's. Okay. We can plug that into our calculator. To simplify, 2 cubed minus 3 times 2 squared. Oh my goodness. That's what happens when you use an old calculator your whole life and then you use this one and the keystrokes are different. So 3 times 2 squared plus 2 minus 3. Okay, so I got -5. And that's still being multiplied by a. So now divide by -5, so a equals -5. So we can plug that back in right here for a. And we'll distribute the -5 to get our final answer. Okay, so -5, so that cancels those two. And plus 15x squared minus 5x. So it looks like C is my answer on that one. 33 is very similar to that one, a little different just because your 0 here involves a complex number, not just an imaginary number. Okay, it has 3 plus 2i. So again, we've got 3 zeros because our degree is n. One of our zeros is -1, so that's going to give me a factor of x plus 1. Another 0 is 3 plus 2i, so that's going to give me x minus 3 plus 2i. And then my other 0 is the conjugate of that, so 3 minus 2i. So x minus parentheses 3 minus 2i. Put those in parentheses so that we remember to distribute that minus sign to both of them. Okay, so x minus 3 minus 2i and x minus 3 plus 2i. Okay, notice the only sign that changes is still that 1 in front of the imaginary part. All right, now we will begin FOILing. We will begin multiplying. So first, do the ones that have the conjugates in them, because that makes your imaginary parts go away. The i's will cancel nicely. So this is x squared minus 3x plus 2ix minus 3x plus 9 minus 6i. Moving on to distributing the negative 2i gives me negative 2ix plus 6i minus 4i squared. Okay, we should be getting really quick at foiling, just like that. All right, now let's cancel. Anything that has an I should cancel, so look for that. 2ix minus 2ix goes away. Negative 6i plus 6i cancels. And then I squared is negative 1, so we know this becomes negative 4 times negative 1, which is positive 4. All right, let's combine like terms. X squared minus 6x plus 13. Okay, and then we will FOIL. So distribute the x and distribute the 1. And then combine like terms. And you're done. Okay, we don't have to look for a coefficient a here because it tells you in the problem that the leading coefficient is 1. So that's just telling you don't worry about solving for a. The a is automatically 1. All right, so looking at our answer choices, it looks like we've got a as our answer. All right, number 35. So on this one, they give you a polynomial and one of the zeros. We've seen this previously, and we want to find the rest of the zeros. Well, if 3 minus 2i is a 0, we know the complex conjugate, 3 plus 2i, is also a 0. So we can cross out a and b because they don't have 3 plus 2i as an option. And so it's either c or d. Now to get that the third and the fourth 0 from there, you could do a couple of different things. The way to do it without a calculator is that you could multiply these two factors together. So 3 plus 2i gives us x minus 3 plus 2i as a factor. 3 minus 2i gives us x minus 3 minus 2i as a factor. Okay, so distributing the negative. On both gives us that, and now we could FOIL that together very quickly. I squared is negative 1, so that becomes a plus 4. Okay, cancel anything that has an I, right? 2ix minus 2ix cancels, 6i minus 6i cancels, and of course my I squared became negative 1, so that went away as well. So I have x squared minus 6x plus 13 is what that comes out to. So I FOILed that together so that I know, hey, that's 2 of my factors. That's the polynomial for 2 of my factors. Now, what you could do is divide that out of this function using long division. You'll get a remainder of 0, and you will get the remaining polynomial. And then from there, you could solve that. So just like the way synthetic division works, long division works as well. We just use synthetic division typically because it's faster, but on this one with the imaginary numbers, I would actually just use long division for this. I'll show you very quickly. So x to the 4th minus 6x cubed plus 8x squared plus 30, x minus 65. All right, so x to the 4th divided by x squared is x squared. Multiply. Okay, multiplying that x squared times all 3 terms there. And then we will subtract. Okay, so this cancels. 8 minus 13 is negative 5. Bring that down. And bring down the negative 65. When two terms cancel, you bring two terms down. Okay, do that again. So negative 5x squared divided by x squared is negative 5. Multiply. Subtract, so you're changing the signs. Plus, minus, plus. And everything cancels, so your remainder is 0. Okay, that is obviously correct because those two are factors, so we should have a remainder of 0. Now you can take this, the resulting polynomial, and set it equal to 0 to get the other two zeros. Okay, solve for x. You get plus or minus the square root of 5. Now that was a lot of work, and that's how you would do it if you didn't have a calculator. Keep in mind, if you graph that, here's the graph of this polynomial, you can see the x-intercepts are clearly not at positive and negative 5. They're at positive and negative square root of 5. So that also tells you that C must be the correct answer. All right, moving on to Descartes' rule of signs. And then we should be finished. So remember, for the number of positive real zeros, you're looking for the number of sign changes on f of x. So for f of x, we have negative 6x to the 9th plus 5x squared minus x squared plus 8. Sign changes, I've got 1, 2, 3. 3 sign changes. So that means for my positive real zeros, I could have 3 or go down by 2, 1. 3 or 1, so not 2 or 0. Now for your negative real zeros, you're looking at f of negative x. So plugging in negative x for all of your x's. Oops, that should be, I wrote that all kinds of wrong right there. X to the 5th. There we go. Okay, so negative x to the 5th minus x, negative x squared plus 8. Now, negative 1 to the power of 9. Anytime you raise a negative to an odd power, the negative is going to stay. So that's going to be negative 6 times negative 1. That becomes positive 6x to the 9th. Again, I'm raising a negative to an odd power here with the 5. So that negative is going to stay. Negative 1 squared is positive 1. So that negative is irrelevant. It's going to go away. So it just stays minus x squared there plus 8. So you can always think of it as the signs are only going to change on terms that have odd exponents. So notice the sign changed on this first term from negative to positive. The sign changed on the second term because the exponent was odd, so from positive to negative. The sign did not change on the third term because your exponent was even. Okay. So you can keep that in mind. Now let's count the sign changes. 1, 2. 2 sign changes. So for negative, you can have 2 or go down by 2, 0. So that's going to be 2 or 0. So C is the correct answer. All right, let's do another one. Number 39. So 39, counting my sign changes on f of x. I've got 1. And that's it. Just one sign change. So for positive zeros, I can only have 1. Okay, so all of them actually only have 1 here. So that's great. Now let's do f of negative x to see our negative sign changes, our potential number of negative zeros. So remember, the sign's only going to change on terms that have odd exponents. Okay, so those three are the only signs that will change. So you're going to have positive 4x to the 5th minus 10x to the 4th plus 5x cubed plus 3x squared minus x plus 20. So I just changed those three signs. So now I'll count my sign changes. 1, 2, 3, 4. 4 sign changes. So for negative, I could have 4, 2, or 0. Remember, you're going down by 2, so I started at 4, the number of sign changes, went down by 2 to get 2, went down by 2 to get 0. So 4, 2, or 0. It looks like our answer should be D here. Not sure why 0 was not included in that list, but it should be 4, 2, or 0, negative real zeros. All right, last problem. If x minus 3 is a factor of the polynomial function f of x, then f of negative 3 equals 0. So think about that one on your own. If x minus 3 is a factor, then f of negative 3 equals 0. So this one is actually false. The reason is, if x minus 3 is a factor, then the 0 that corresponds with that is x equals 3. And here's why. X minus 3 equals 0 gives me x, adding the 3 over, gives me x equals 3. So the 0 is positive 3. So that is f of 3 equals 0, not f of negative 3. The sign changes on that. All right, and that's it for your review. Hopefully that helps, and good luck on the test tomorrow.